So my first question is, how many of you know about ways to bypass hardware firewalls? Hands up. Okay, cool. But at the end of the presentation, I promise all of you will be able to do that. So this is my name. This is where I work. And we mostly do antivirus testing, but we do it in a special way because we always try to find new ways to bypass these antivirus systems. Sometimes it's challenging, sometimes it's not. These are the things I'm really proud. And as you might know, I'm really into hacking. This is my work, this is my hobby, this is what I do 24/7. Okay, now I want all of you to close your eyes and think about hacking high security systems. And what is the first picture that pops into your mind? Okay, was it this one? We will do something pretty similar to this, but with less cables and less hands-on guys. So here is the mission I want to achieve during this presentation. Let's say that, for example, I'm a spy and I want access to a secured, hardened, remote desktop server. For example, this remote desktop server can contain some confidential documents or stuff like that, some application which has to be hardened or something like that. The main thing is that I really need some command and control channel to this RDP server, and I need it in a persistent way so I can access it anytime I want. And I need this command and control channel to upload and download files or even for remote code execution. In an ideal world, it couldn't be easier. I can infect a client which has access to this RDP server. I steal his passwords. I connect to the RDP server with this password. I drop my malware there, start the command and control channel, and mission accomplished. But sometimes hacking is not so easy. Imagine a scenario where the RDP server is not directly reachable from the internet. On top of that, there is some two-factor authentication used to access this RDP server. And this means that even if I can steal the password, I won't be able to log in because I don't have access to the token seeds. On the other hand, the drive mapping is disabled between the clients and the remote desktop server. There is no direct file copy between the servers. And the most important thing is that there is some very restrictive hardware firewall between the clients and the remote desktop server. And this restrictive firewall only allows the inbound communication from the clients to the remote desktop server port. That's all. And I also added some advanced protections to the server, like application whitelist, so people can't start any program on that server. And in my case, I have chosen the default Microsoft Applocker solution for that. Okay, you might ask whether this scenario is realistic or not, and I had to admit that once upon a time, I met a client who had a very similar network. And we were talking about whether it is possible to hack this secure RDP server or not. And although we all know that it is possible to hack it, we were not able to prove that. So you might guess whether I was pissed off or not that we had no time to hack this server. So I went home and started to code. Now this is what I want to achieve. I am the spy, I am the attacker, and through an infected workstation, I want this command and control channel opened to the secure remote desktop server. And once a wise man said that in hacking, there is no such thing as impossible, only things that are more challenging. And if you agree with this wise man, hands up. Okay, that's the spirit. I don't want to start the whole story from the beginning, so let's say that I have already infected a client workstation. There are thousands of ways to do that. And in my hacking scenario, it is also needed that, for example, I have access to a test RDP server. And this means that I know the configuration of the server, how it looks like, what services are installed, and so on. And as you can see, this is clearly a post-exploitation scenario. Now, if you are a red team member or pen tester, ethical hacker, hands up. Okay. And if you are on the defensive side, blue team members, hands up. Okay. For the red team members, I'm going to show some new tools you can use during your hacking. And for the blue team members, there will be some tricky things you have to look for during daily log analysis or, for example, in an incident response scenario. Usually when I have to solve such a complex problem, what I do is that I divide the problem into smaller pieces and try to rule all of them one by one. So in my case, I thought that if I can drop my malware into the RDP server and somehow bypass the application whitelist and start my malware there, elevate my privileges to admin level, and bypass the hardware firewall, in this case, I would be able to do my interactive remote command and control channel. And in my presentation, the first and the fourth step is important because here you will see the tools I have created. The second and the first step, it's publicly documented on the internet, so there will be nothing new here. Okay, so let's start with the demo. This is the configuration file of my, I call it user simulator. And basically, what you can see here is that it sleeps for 1 second. It presses the Windows and the R button, which is to start a new command. It will type in WinWord, sleep something, and to do this demo a little bit more interactive, I want to ask you to tell me a color: pink, purple, red, yellow. Say something. Come on. Black, okay. And also tell me an animal name. Sorry? I can't hear. Monkey. Monkey, okay, black monkey. Cool. So this is the configuration file. And here I start my user simulator. It starts WinWord. Hit escape to bypass the activation screen. Black monkey is written there. And through the key combination, I can do everything like changing the font size, changing the color, etc. So the main thing is that I can start new applications and I can always type something into the active window, and meanwhile I can also change what is the active window. So far so good. But how can this tool helps me to drop my malware into the RDP server? What happens in my malware is that it waits for the user to connect to the RDP server with this two-factor authentication. And after successful login, it will create a screenshot. And it will show the screenshot in the foreground for the user. And meanwhile, it also blocks the keyboard and the mouse for about 20 seconds. The user experiences, holy shit, this froze again. So, and what happens in the background that because the RDP window is the active one, it will start my malware, the Microsoft Word, in the RDP server and drop some ASCII encoded payload into the Word, create some macro code. The macro code will read this ASCII payload, write out some binary files, and start the binaries. There are also many use cases for this user simulator. For example, I have already used this to configure the antivirus of the system through the graphical user interface, because this is a new malware. It has not been added to any signature list. So I can start it, and I can use it to configure the AV to add some directories as an AV exclusion, for example. Another great thing I can do with this user simulator that when I, as an attacker with user privileges, try to install some new trusted root certificate authority to man in the middle some SSL connections, there is a warning dialog popped up to the user, like, do you really want to do that or not? And my malware can basically detect this new warning dialog and instantly accept it. And the funny thing is that this attack even works with browsers with certificate pinning, because it turned out that the user installed certificates are also accepted even if certificate pinning has been used. After I wrote this tool, and I was very enthusiastic and told everyone what I made, one of my friends told me, very good, but why don't you use AutoIt? And I was very sad. But it turned out that because it is not open source and some functions were not implemented in it, it was not a possible way for me to do this attack through AutoIt. And meanwhile, it turned out that attackers are using this technique as well. And if you generate any non-malicious AutoIt file and upload it to VirusTotal, 7 out of 50 will detect it. So this is not a good thing if you are an attacker. Okay, let's go to the second step. Now I was able to drop my binary on the RDP server. How will I start it even with Microsoft Applocker installed? First, because I know nothing about how Microsoft Applocker works, I started to read the official Microsoft documentation. And Microsoft was kind enough to give an awful lot of different ways how I can bypass their product. So this is very good from them. For example, you can use scripts, macros to bypass a default policy. The best one is that if you set a flag in your executable, which I will call basically bypass Applocker flag, and set it to true, then the Applocker policy won't be enforced on your binary. And there are an awful lot of different ways. And it is also important to know that in a default policy, an administrator is not enforced by Applocker, which really makes sense because the administrator has to install the programs so the users can use it. But I choose the different way in my scenario, and it is the power of Microsoft Word and Microsoft macro code. Because it turned out that from Visual Basic macro codes, you can do an awful lot of different things. For example, I'm not sure, did you know that you can do port scans from Visual Basic macro code? You can load DLLs directly without starting any new executable. And on top of that, you can run direct shell code from Microsoft Word macro code in Visual Basic. So next time when you have to hack a server and there are no applications installed on the server, but you have Microsoft Word, think of it as a really powerful hacking tool. Now, after bypassing Applocker, I had to elevate my privileges to administrator level, and this is needed for the fourth step, where I have to install something with administrator level privileges. Okay, so again, there are a lot of ways how you can do that. In my presentation and demo, I will use Windows Server 2012, and it turned out that there are not many local privilege escalation vulnerabilities in this new Windows Server. But there are also, you might find a new one and use that to escalate your privileges from user to admin, or you can just exploit any unpatched vulnerability, or usually the easiest way is to find a third-party module and use that to escalate your privileges. And in my case, I have chosen a vulnerable third-party service to do that. As you can clearly see in this picture, this user, this myvulservice.aec is writable to the terminal server users, and meanwhile, the interactively logged on users can stop and start the service. So if you can stop the service, change the binary and start the service, and even it runs with system privileges, then you will be able to escalate your privileges. Yeah. Sometimes Microsoft is not very user-friendly, so this is how you should read the output. So the A is hello, the RPVP is service start, service stop, and IU is interactively logged on user. It took me some time to figure out what is really written there. Okay, so fourth step. I was able to upload my malware in the first step to the RDP server. I was able to bypass the whitelist, and I was able to escalate the privileges from user to admin. Now I have to find a way to bypass the hardware firewall. Because it is so restrictive, I am not able to connect to it via bind shell, because the firewall will drop the incoming connections. I cannot use any reverse shell, because again the firewall will drop all my reverse connects. And even in my case, every covered channels were blocked, like DNS or ICMP, IPv6, UDP, or even there were no proxy to hop my communication, which means I don't have shell, and this is very sad. And if you think about different hacking scenarios, there are some ways to bypass the firewall. For example, you can use exploits which will reuse the TCP socket, or you can use some lame web shell, but all of these have its limitations. For example, it's not persistent, it's not interactive, or something like that. So my first idea was that after I can run code with admin privileges on the RDP server, how about to make an application which monitors all the incoming network traffic on the RDP server, and if the starting bytes of the network flow matches with a magic byte I set, I can see that this is a traffic which has to be handled differently, so it should not connect to the RDP server process, but it should be forwarded to my bind shell, for example. But it quickly turned out that this concept has its own drawbacks. For example, every application, hacker application, had to be rewritten, and or even worse, had to be rerouted through a custom wrapper proxy, which adds and removes these magic bytes. And my second idea was that how about using the TCP headers for these special magic bytes? And I chose the TCP source port to this. So let's say that if this application, which will be basically a kernel driver, on the server sees that the TCP communication is from this special source port, it won't allow the RDP server process to handle the connection, but rather it will redirect it to my bind shell. If you want to make this attack to work on Linux, it is pretty easy because you have IP tables, and one line of IP tables rule will easily do that. So as you can see, if the TCP source port matches this special 1337 port and the destination port is, for example, SSH, then I can redirect the traffic to my bind shell, which listens on 31337. So this is how it looks like in a network diagram. The attacker or the infected workstation sets the TCP source port on the client side, connects to the secure remote desktop server RDP port, and the firewall will see this RDP port only, but the kernel driver will catch the communication and redirect it locally to the bind shell. So if you are into the Lord of the Rings, this is something similar, that this guy is the very dumb stateful firewall, and this dumb stateful firewall will inspect all the packets. But they will never check what's inside that traffic, and it might be that it's not RDP traffic at all, but some backdoor. And at the end, you can separate the backdoor traffic from the RDP one. And yes, today firewalls are usually so stupid. So as I mentioned, I had to do this on the kernel driver level because Windows already implemented this network filter driver application interface. And in order to install a kernel driver on a new Windows 64-bit system, it is not trivial because a trusted signed driver is needed in order to do that. But luckily, I have found a great framework called WinDivert, and my kernel driver is basically implemented in this framework. And they were shipping their kernel driver with a trusted signed driver, which means that even if I add my new functionalities to the kernel driver, I can interface with the trusted and signed driver. And I think it's pretty cool because, you know, someone ships something that everybody thinks it's okay and secure, and with the interfaces you can do anything you want. with that kernel driver. As always, there are many ways to bypass this signed kernel driver protection on Windows. For example, rootkits usually do that. The best one was when the Ouroboros rootkit used an old, vulnerable VirtualBox kernel driver, and I think it was a buffer overflow vulnerability it exploited in it, and by exploiting that vulnerability, it was able to run kernel level operations on the machine. Now the next step is that how am I able to set the TCP source port for any application, and it quickly turned out that the almighty Netcat will be able to help me in this case, because I can set the TCP source port for the communication, and it basically acts like a proxy. Now, some demo. So here you can see the server side, and I'm going to start the bind shell on the RDP server on port 31337. And I'm also going to start my kernel driver. So when it sees a new TCP connection from port 1337 to the RDP port, it will redirect it to my bind shell. And this is the client side, where I connect to the RDP server with the special source port set, and I'm connecting to the RDP server port. And as you can see, the connection has been established, and it works as expected. And when I looked at the traffic from the kernel side, I can see that it is from the special TCP port coming to the RDP server port, as you can see. But after that, because my kernel driver changes the traffic, you will see that from the user space, it looks like that it connected from the special TCP source port, but directly to the bind shell and not to the RDP server. And because it's a TCP session, it goes back and forth, so it's a stable connection. I was thinking about some improvement possibilities, that it would be great if my bind shell will be listened on the local host only, because with that I can even bypass software firewalls running on the RDP server. But it quickly turned out that because there is really no place like localhost on Windows, this won't work, because in Windows the localhost interface is not there, it's just simulated, and because of that this very deep level kernel driver magic won't work, unfortunately, but it would be cool. Again, this tool can be used in an awful lot of different scenarios. For example, let's say that you hack the web server and you already have admin privileges there, but you cannot do your persistent command and control channel because of the restrictive hardware firewall. In this case, you can use this tool and set it up in a way that every traffic coming from the special TCP source port to the web server will be redirected to your bind shell. It can be also used to proxy the traffic. So when you already hacked a server, you can jump to another host and attack those as well. Now, let's see the whole solution together, the whole attack. So the malware waits for the user to log into the RDP server with this two-factor authentication. It creates the actual screenshot from the user desktop, put it in the foreground, and disable the keyboard and the mouse. So the user will see that it froze again. Meanwhile, my malware is simulating the keyboard events in the background, and because of the RDP server is the active window, everything will happen there. So my malware starts WinWord, drops the ASCII encoded payload, creates the macro code, and the macro code running will write out all the binaries which needed for the attack. And after that, I can bypass the application whitelist with this powerful tool called Visual Basic Macro Code. I can escalate my privileges to admin thanks to a vulnerable third-party service on the RDP server. With the admin privileges, I can install my kernel driver, and I can also start my bind shell, and I have all to my persistence command and control communication. And the main thing here is that even after the user quits from the RDP session, I will be able to come back to the RDP server anytime I want. The only thing I need that the user workstation should be online for me, so I can route all my traffic through the user workstation. So this is how it looks like. I, as an attacker, access to the infected workstation, setting up the TCP source port and connecting to the RDP server port. I can reach my bind shell. Now let's see it together. So here I am connecting to the infected workstation, and I set up some port forward, which will be needed later. And as you can see, the calculator is running on this desktop. So this is the infected workstation, which you can see in the background, and the putty is the attacker. I have already uploaded all my tools to the victim, so I start my hacking user simulator, and it waits for the user to connect to this secure RDP server. And what's important to see here that this temporary directory is empty at the moment. What happened? And my user simulator from the infected victim machine is running. It starts WinWord, creates a new document, drops 71 pages of ASCII encoded payload, starts the Visual Basic macro code, copies all the macro code there, and starts the Visual Basic macro code, which loads the DLL in the background, which basically does the privilege escalation, and my Meterpreter bind shell started with system privileges, and also the hardware firewall bypass kernel driver is also started. Now, from now on, basically my attack is done, but I still have to do some background things to reach this background communication channel. So I set up the source port on the infected victim machine, and through some I'm not sure, I think it's 5 port forward in this whole scenario. But at the end, you will be able to see that I can pop the shell on the restricted Windows Server 2012 server. Yes, here you can see that the connection has been established and the Meterpreter stage 2 DLL is loading. Meterpreter session opened, and for the second time also the shell opens. So I have interactive remote code execution, persistent access to this RDP server. Now, as you can see, this was rather long, so I'm going to show you how it really looks like, what is the user experience. So this is the user's desktop. He connects to the RDP server, and as you can see, the mouse and also the keyboard is blocked, so the user can't do anything. But after 17 seconds, he gets back his RDP shell. But what happened really in the background is that I was able to drop my bind shell and my kernel drivers on the RDP server. So, for the red team members, pen testers, I showed 2 tools for you which you can use during your penetration tests. The first one is able to drop malware through a remote desktop, and it is important to note that it is working also with Citrix, not just Microsoft Remote Desktop. And I think it should work with VNC as well, but I haven't tested that. And also, if you can achieve admin level privileges on a Windows server in order to install some kernel driver, after that you can bypass or fool the hardware firewalls using my kernel driver. And for the blue team members, as you can see, even very restricted, hardened environments can be hacked, and every additional layer of security can be bypassed. And I have heard many times that this RDP server is a good separation, and it adds an additional layer of security because malware is not able to pass through this RDP session because it's just a GUI interface, not like an SMB connection. But as I have proved, RDP is a real interface for malware propagation. If you want to protect against this particular attack, it is a good idea to use some next generation firewall which can inspect the network traffic, and it will instantly see that this network traffic is not RDP. It is something different, and I only allow RDP protocols on this port, so the next generation firewall can block that traffic. But my current research is on that I am building a new proxy which will basically wrap all my communication, and it will look like something like an RDP protocol in order to fool these next generation firewalls. And also in a log analysis or incident response scenario, you should not blindly trust your firewall logs, because on Linux or Windows, it is very easy to mess what the hardware firewall sees and what really happened in the background. And there is one more thing, basically 2 things. Both of my tools are available as a Metasploit post module. You can download it from the GitHub page. And that's all I wanted to share with you. Thank you for your attention.